Hi, welcome back. Let us continue from where we ended. Remember, I told you that before a body can take a bend along a curved path or along a circle, the body itself should produce its own centripetal force. In other words, without this centripetal force being produced by the own body or by the body itself, it cannot take the bend. In other words, I'm trying to say, how can we create our own centripetal force? And this is the same as sources of centripetal force. Please, are you okay? Yes, that's it. Sources of centripetal force. So how the body can maneuver its own ways to produce its own centripetal force is the same as the sources of centripetal force. So sources, we have sources of centripetal force. Are you okay? So now, how? Let's take this example. I told you that let's consider a stone tied to a string or a thread and while in a circle. And clearly we're trying to say that that's an example, or the stone will perform what? Circular motion. Are you okay? So this is the string or the thread, and this is the stone or the ball. Then you wound it in a circle. So that means the stone is performing a circular motion. Now, if this body doesn't produce its own centripetal force, the stone cannot undergo circular motion. Please, are you okay? For example, when I have, let's consider this, please, we are improvising. Are you okay? Let's say this is my string or this is my thread, and this is my stone. Now, before I while this in a circular form so as to perform a circular motion, there should be another force. Are you okay? So it means we are using a force to produce another force. Please, are you okay? So now, before you produce your own centripetal force, it can only be done when you use a force to produce your centripetal force. So it means you are using a force to produce another force. But the force here you are interested in is what? Is the centripetal force. So in other words, we are using force to generate the centripetal force. Please, are you okay? So it is not surprising to hear that how can you produce your own centripetal force? Then you'll be like, oh, what's this? Is this question a real question? Are you okay? The question is a real question, okay? It's a tangible question. So just take note, we use a force to produce another force. So in other words, we are using the force to produce our centripetal force. So let's come back. So if I write this in a circular form, you realize that there is a force operating within the thread or the string. Are you okay? So it means in the absence of that force, you cannot while it in a circular form so as to perform circular motion. So now, when I while this in a circular form, in a circular form, you realize that there is tension produced in the string. Are you okay? So it is this tension produced in the string that will help the body as a whole to perform a circular motion. Please, are you okay? So you can say that, let's consider, so a stone tied to a string or a thread can take a circular motion? Yes. But how can you produce your own centripetal force? You can produce your own centripetal force by what? By the introduction of the tension in the string. So it is this tension produced in the string that is helping the body as a whole to perform the circular motion. Are you okay? That is our one. So tension produced in the string will help the body to perform circular motion. So that is one. And number two, let's consider this. Our day in and day out, our daily activities. You travel from one place to the other. Are you okay? Or if you don't travel, or you don't like traveling, you do work. Are you okay? You do work to go and buy food and what have you. So now, before you can take a bend, are you okay? You want to take a bend. Let's say you are moving straight and you realize that, oh, you want to pick something from here. So that means you have to take a bend over there. That means you have to produce your own centripetal force before you can take that bend. The same also applies to the cyclist or drivers driving, let's say, their vehicle. Before they can also negotiate a bend, they will have to produce their own centripetal force. How do they do that? Let's consider human beings. So you can produce your own centripetal force by using or by the help of the sole of our feet. So you know that the sole of our feet is making in contact with what? With the ground. As a result of that, there is what? There is friction. There is a frictional force operating over here. How did we produce this force? This centripetal force. We produce this centripetal force by producing what we call what? The frictional force between, or that is it, between the sole of our feet and the ground. So if there isn't friction or frictional force produced by ourselves, we cannot take a circular bend or a circular path, or we cannot negotiate a bend. The same also applies to the vehicles and the cyclists. See, the road or the ground is, let's say, the tie of the vehicle or the tie of the moving body makes in contact with the ground or the road, and as a result of that, there is friction pronounced, and this friction will now help us to take the bend. Please, are you okay? Now take note. Let's say if you are at a place where the ground or the road is very, very smooth. In other words, if you are at a place where the surface or your surrounding is very, very smooth, friction is not well pronounced over there. Are you okay? Friction is pronounced, or is more pronounced on rough surfaces. Please, are you okay? So if the surface of the road or the ground or what have you is very, very rough, then that means friction is also what? High. Are you okay? So the higher the friction, the higher the centripetal force that will keep the body to perform the circular motion. And when the body is on a smooth path or a smooth surface, friction is not pronounced. In other words, friction is absent, or if friction is even produced there, it is very, very minimal, and that body cannot take a bend over there. Please, are you okay? So our second point is the frictional force that exists between the sole of our feet and the ground help us to take the circular bend. Are you okay? Yes. Number 3, let's say we said an example of a circular motion is the earth revolving around the sun. Are you okay? Now you have the sun over here and you have the earth over here trying to move about. Are you okay? Now when you have bodies over there, the force that operates between two bodies and depend on their masses is what we call the gravitational force. So gravitational force is any type of force that operates or that exists between two bodies and also depends on what? On their masses. That's what gravitational force for you. And now, before the earth can move about or around the sun, it has to produce its own centripetal force. How is it going to produce its own centripetal force? It has to produce what we call what? The gravitational force. So the gravitational force that exists between the earth and the sun will now help the earth to move about the earth. And this is applicable to all planetary motion, all bodies. You see, the planetary motion, that is earth revolving around the sun, you see, and the moon revolving around the earth, and so many other planetary motion. Are you okay? That is that. Let's consider this. Fourth example. Let's say, remember I told you that we have the nucleus contain the protons and the neutrons. Then you have your electronic shells with your electrons around, revolving around the nucleus. Now, before these electrons can perform circular motion, it means you have to produce your own centripetal force. Here, how do you produce your own force over here? So the electrons or the negative charge over the negative charge body over here can only revolve or can only perform circular motion about the nucleus when there is an electrostatic force between what? The charge bodies over here. So it is this electrostatic force of attraction that is between the electron and the nucleus that will help the electron finally to take what? The circular bend. So in other words, in the absence of this electrostatic force, the body cannot undergo circular motion. So please you have realized that for you to produce your own centripetal force, with the example so far, you can realize or you can deduce that we use one force to produce another force. Are you okay? You use one force to produce the centripetal force. Please, are you okay? You can consider a lot of examples. Let's say if you have a charged body, or introduce a charged body onto a magnetic field. You know that whenever a charged body enters a magnetic field, the charged body will now will be deviated, or it will assume a semicircular path or a semicircular bend. Why? Why is it assuming that shape or that form? It is doing so because there is a force called the magnetic force. So it is this magnetic force that will enable the charged body to undergo the circular motion. I hope it's understandable. So I beg you, don't do chew and pull. Are you okay? Yes, so you can still just like my video and subscribe for more videos. Are you okay? Stay safe. Thank you.